Okay, so this stuff is from 13.2, where we're starting to get into this idea of radians and angles on this on an axis, so that we can compare them to other angles. Number 10 wants me to draw a picture of an angle that is 6 pi radians. Well, that may not be the easiest thing for someone to do, so I might want to convert that to degrees. I would do that by multiplying by 180 over pi, so the pi's would cancel, and that would give me 6 times 180 is 1080 degrees. That's obviously more than one rotation, so I'll come around once. If I take 1080 minus 360, I end up with 720, which is still more than a whole nother rotation. I'm going to go around a whole nother time. Of course, I went up because it's a positive, so that took another 360 off. Leaves me with 360. I still need to make a full another rotation all the way around. This is a 1080 degree angle, or a 6 pi radian angle. An interesting thing about this, just real quick, okay, if we talk about, how far does it around one rotation? Well, on our unit circle, okay, 360 degrees is the same as 2 pi. Well, 2 pi goes into 6 pi 3 times, hence 3 rotations. All right, so that's your answer for number 10. It's just those 3 rotations. Number 9 asks us to find coterminal angles with 9 pi over 2. Coterminal means, again, we go around the circle. Going around a circle is 360 degrees, or we just said 360 degrees is equal to 2 pi. So I need to add or subtract 2 pi from my 9 pi over 2. And my goal is to get a positive and a negative rewriting of this angle. So something that's also the same, but is another positive one plus a negative one as well. So 9 pi over 2 plus, I'd like to add 2 pi, but I wanted to have a denominator that's the same so I can combine them. So how many pi over 2 reduces down to 2 pi? Well, that's 4 pi, because 4 over 2 is 2. That means I have 13 pi over 2 as one solution. It's positive, so that's one of the answers, but I also need a negative. I would get to a negative by subtracting 9 pi over 2. I'll subtract 4 pi over 2. This is 2 pi, so I'm subtracting a full rotation. That makes it 5 pi over 2. I'm going to subtract 4 pi over 2 again to get 1 pi over 2. And I'll subtract 4 pi over 2 again to get negative 3 pi over 2. Finally, a negative answer shows up. What we're doing is we're unwinding something like this. See, it's been wound up so many times. Every time I subtracted 2 pi, I took a circle off until I could get to a negative solution. Okay, that was my goal, was to unwind as long as it took to get a negative answer. Now, interestingly enough, this is a positive solution, just like 13 over 2. And so is this. Any of these 3 would have worked as our positive solution. But I had to have the negative 3 halves as my negative. And I could subtract 4 pi over 2 again and get negative 7 pi over 2. I could do this all day. It's not going to change anything. These are all equal in angle. They land in the same place. All right. Then we get to 24. We have 315 degrees. We'd like to convert it, if possible, from degrees to radians. So the conversion factor that I have is 180 degrees to pi. They're the same thing. So 315 degrees, I want to multiply by, I'd like the degree to go away, so I'll put it in the denominator and put pi on top. Well, 315 pi over 180, that's going to reduce. For sure it reduces at least by 5s. But I'm going to suggest that it actually reduces by quite a bit more. Let's see if we can see what that'll reduce down to. 315 and 180 actually reduces down to 7/4, so 7 pi over 4. That means that 315 was divisible by 7 and 45. Both of these were divisible by 45. Now you may not have known that right off, but here's a little interesting fact. We got 7 pi over 4. I know this is not a hard process, but watch what happens if I look back at the unit circle. There's 315 degrees. There's 7 pi over 4. The conversions for some of these have already been done. So it's never a bad idea to take a peek at that circle you have and see if you already know its value. 35 asks me to find the arc length and the area for a sector of a circle. Let's just go ahead and get our circle out here. Okay, and we're just going to do a quick sketch. This is S, and this is A. The angle in here is my theta, and there's my R, my radius. So I want to know how much area this fills, and I also want to know how long the edge is. Well, the problem is that theta needs to be measured in radians. Right now it's measured as 150 degrees. I can convert this the same way I did just right here, or I can think about the 150 degrees and see if perhaps it's in the unit circle. Without converting, I know it's 5 pi over 6. So I'm going to cross that out and put 5 pi over 6. This unit circle is full of useful information that helps speed up the process. So we've got 12 for the radius, and we're multiplying by 5 pi over 6. When we do that, for number 35, we end up with about 31.4 feet. Okay? 31.4 feet. And that seems familiar because 12 over 6 is 2, 2 times 5 is 10, 10 times pi is 31.4 feet. Down here I get 1/2 times 12 squared times 5 pi over 6 equals, when I multiply those together, I get about 188 square feet. Okay? Again, this is just number crunching. Throw it in the calculator. All right, we have just one more to look at together today, and it's this, the cotangent of pi over 8. Well, I have a problem. I don't actually know how to find the cotangent using my calculator. This is not going to be a known value. But I do know that the cotangent of an angle is equal to 1 over the tangent of the same angle. We talked about this, it's the reciprocal. We're flipping it. So we're actually going to take the tangent of theta and take 1 divided by that tangent. If we do that, it'll flip the result. We're not flipping pi 8ths, that's the angle. We'd be flipping the result of the multiplication. So cotangent of pi over 8 equals 1 over, and I'm going to go find out what the tangent of pi 8ths is. First thing I'm going to do is grab my calculator and clear off whatever I've got. I want to make sure my mode is correct. See, I'm in radians with pi 8ths. So let's go to radians. And now I'm going to hit tangent of pi divided by 8. Enter. I get 0.414. So 0.414. And I'm just going to use my calculator to help finish this off. I'm going to say 1 divided by the answer equals 2.41. And I'll probably use about that many decimal places. Cotangent of pi over 8 is equal to, I'm going to say 2 or 0.2? I know you guys already know the answer. 2.41. And there you have it. That's it. So you might have to use those inverse properties or the reciprocal properties on some of them. Some of you will, some of you won't. But good luck, and I hope it works out really well for you.